What is up, YouTube? What?
It's supposed to be red sometimes.
What, this?
Yeah,
Yeah, that's my startup. Sorry, smartwatch, yeah.
Why is it like that?
Oh my god.
Why is it red?
Why is the band red?
Yeah. No,
That's
why
He's
is
an Apple employee, bro.
No, why is
Come on, how dare you ask an Apple employee why is your band limited edition? This is limited edition, if you must know.
Not sponsored.
Alright, what is up, YouTube? We're back here again with another tutorial. The third tutorial of our peripheral library. Everyone's so tired, Jesus. So ADCs, what are ADCs? So this one actually has only 6 slides. So ADCs stands for analog to digital converter. So whenever you are reading some sensor value, chances are that if that sensor is complicated, you usually talk to it via I2C or UART. Or no, not UART, I2C, SPI, CAN, or like a whole bunch of other stuff. Or they actually just provide your input that you want as a voltage, and then you can map that voltage into something that actually makes sense, right? So STM32s have multiple pins that are ADCs. You can read a simple digital value that usually linearly maps to some other value. So an example of this is temperature, or voltage, or current, or any other thing, right? Good. So let's go here. So this is an example of a temperature measurement. This is a really terrible picture I just found on the internet. So it says to analog pin A of Arduino. But okay, our thermistors work the exact same way. So you usually put this thermistor with another series. So what we're trying to do is to measure a temperature. So what thermistors are is that they give you temperature measurements. It's basically a resistor that its resistance changes with temperature, right? So whatever temperature your circuit is at, this guy's resistance changes. Therefore, this voltage divider will give you a different voltage. So do you guys know what a voltage divider is? No?
Voltage.
Yeah, it's basically, yeah, it's exactly that.
Is it like a potentiometer?
Yeah, to a certain extent, yeah. Anyways, a potentiometer is a voltage divider, but a voltage divider is not a potentiometer necessarily. But it's very similar. So basically what happens is the temperature changes, this guy's value changes, therefore this voltage changes, and this line basically goes into your MCU, and then you can read from this, you need to configure this pin as an ADC, but once you do that, you can read the voltage, right? And then you can know what the temperature is. All right, so let's go to the next slide. Let me make this full screen. So this is another example, simple voltage measurement. So I actually got this from your tutorial board. So let's just go ahead and take a look at the link, because I hope for all of these, I just want you to, we actually had the tutorial board open. So this is the schematic for the tutorial board that we use here at Midnight Sun 14 for all of those people in the future that are gonna watch this video when we're making Midnight Sun 16 or 17.
Yeah. What happened to 13?
What happened to 13? Because obvious reasons. So we can't be called MS13. Come on.
Just wait till someone doesn't know and looks it up.
Yeah. For all those that are watching this video, you can Google what MS13 is and exactly know why we are not MS13. We make a solar car. We don't kill people. So over here you can see that this potentiometer. What a potentiometer is it's basically a variable resistor. So you can actually change the resistance using a screwdriver. So I'm gonna have Avery film me right now in a second. No, don't wait. But yeah, basically that's how it works. And this goes to PA0. Pot. This pot means potentiometer. And then if you come back down here to the mezzanine, you can see where this guy goes. It goes to PA0. So yeah. Okay. No, that's good. So yeah, you can start filming. So this demo is on the Firmware XIV project. The project is called Tutorial Board ADC. If later on, if you guys want to go through and see what's happening. Okay, so let's just program this. So bring this close here. Close here. Close. Yeah, there you go. Ooh, wow. Look at the quality on this camera. It's beautiful. So this right now does not have the firmware that I'm about to show you guys. Oh, actually, wait. Okay, stop this. Let's take a look at the code, because I forgot to take a look at the code. Are you filming stuff?
Yeah. Click on the code.
This is getting screen recorded. Come on. Okay.
Screen recording.
Tutorial board ADC. This is the project. Okay. So let's take a look at it. Oh my God, that is slow. All right. So you have the potentiometer address. If you guys remember, it was PA1, right? So if you go here, it's PA0. Yeet. Okay, so I don't know why this is supposed to work. Maybe that schematic is outdated.
What's up, PA1?
Is this tutorial 2.0?
That was tutorial 2.0. No, that is actually the latest version. So probably Ashmika made a mistake, so I'll let her know. We can try right here. So if one doesn't work, we can switch to 0.
Because I ran it before.
Yeah, I ran it before too. Like I actually ran this, so I'll let her know. There's been hella mistakes on this. Oh my God. It's okay. So we have the potentiometer pin settings. So direction is in, state low, resistor. We don't use any resistors because it already is connected to a potentiometer. Alt function analog. So make sure that this alt function is set to analog. Otherwise, your GPIO pin will not work. Because right now you're actually using an ADC instead of the GPIO pin. Stop filming me, man. Come on. It just distracts me. Anyways, so we initialize the pin just like any other GPIO pin. And then we do ADC init, and then we do a ADC mode, right? So ADC has 2 modes, single and continuous, right? I actually never gotten the continuous mode to work. But here's the difference between the two. Hopefully I'll get it to work someday. In the continuous mode, the ADC will continuously read values, right, with some latency. And then whenever you read from it, it presents that value to you. Whereas in the single mode, whenever you want a value, you tell the ADC to get you a value, and then the ADC will provide you with that value.
Wait, don't
Right.
I need continuous mode?
Sorry?
Don't I need
It's
continuous
an
mode?
analog.
What?
Or I mean,
pedal?
What, sorry?
No, for his pedal.
Yeah, don't I need continuous?
You will need continuous, yeah.
Ah, I see.
Yeah, you'll get it working, don't worry. You're a smart guy, you can figure things out.
Oh.
So we have single mode and continuous mode. So the difference is the latency. I mean, you could, for example, use the single mode to continuously read from the pedal,
Yeah.
So you
right?
just keep on.
Yeah.
No, like from your perspective, your program will continuously this.
continuously
Sorry,
True.
this your program doesn't care because this is just a configuration parameter. What happens is that when you set this, you get your values a little bit slower when you set this, right? But your program will regardless need to do a read raw or read converted, right?
And then you bring up like an interrupt every single time.
And then you don't bring up an interrupt. No, that's just like to read from the channel,
Oh, okay.
right? So depending on what kind of driver you write. Wow, this screen is amazing. All right, so let's get back to the project. So ADC or tutorial board ADC. So what I'm doing here is that I'm basically reading from the potentiometer ADC channel, and then after I program it, I'm repeatedly printing out potentiometer data, and I just delay it by 200 milliseconds to just not have the screen go crazy. Yeah, that's pretty much it. And then, oh, by the way, so there's methods of ADC get channel and then set channel, right? So get channel, set channel. So whenever you're using a GPIO with a potentiometer capability, you would have to basically take a look at the controller board to make sure that, like, this is for the hardware people. They need to set this to a GPIO ports and pin that supports ADCs. If it doesn't, then this wouldn't work. And internally, all of these pins are basically connected to one ADC block. That ADC block has multiple channels, and each channel is mapped to a GPIO pin. So how do you figure out what channel is your pin for? We have this function that basically gives you that channel, right? So ADC get channel will give you that channel. So you just pass it the potentiometer address, and then you have this potentiometer channel variable that I just declared, right? So I pass in the pointer, and that will give me the channel, right? So this variable will get, this pot channel variable will get updated after I call this function. And then I set the channel to true. I think this just enables that channel. So ADC.h, let's take a look at that. Set channel. Yeah, so it says enable or disable a given channel. A race condition may occur when setting a channel during a conversion. However, it should not cause issues given the intended use cases. So if that doesn't make sense to you, don't worry. Okay, potentiometer, ADC, what was I called? Tutorial board ADC. All right, so we got the channel, we set it, we enabled it, right? And then, so by the way, I'm setting a different channel as well because these guys have internal thermistors, so you can actually internally find the temperature. They're not that accurate, so this is what I had previously when I was just playing around with it. So I can just remove it, doesn't matter. Well, let's just leave it there because I don't want my code to just fail. Apparently I'm using some other things down here. Anyways, I get the potentiometer data and then I pass it to the output, right? So let's just start running this. And now is when Avery films me. Hi, there. Okay, there you go. So, tutorial board button, it's not tutorial board button, it's tutorial board ADC. So board underscore ADC. And before I program this, let's just go ahead and look at minicom to see what, okay, there we go. So now I'm listening on the UART and program. Boom. So you can see that it repeatedly is sending me the potentiometer data. So it's about 2000, right?
Is this supposed to be decreasing?
No, it's not really decreasing. It goes like 6.
First one 0 for any particular reason? I think it was 0.
Yeah, it takes a while until it gets you some data. So now with my nails, I'm going to try and change.
You want this?
Oh yeah, give me that. Okay, beautiful. Oh no, you took the knife in. Come on, man! I already had it out, ready for action.
Knives are dangerous.
You are right. What kind of a firmware lead am I putting your guys' life at risk? All right, there we go. So now we're going to change the value of, so zoom in. Like really in. Okay, there you go. You see that? See this? Oh, whoa! Damn, this camera be lit. So shout out to Apple for making amazing cameras. Oh my God, look at that fidelity. You can, like, my eyes can't see that. Okay, I'm done flexing with my phone. Okay, stop shaking the camera. Okay, so now I'm going to change the state of this, like,
It went
thing.
to 300.
So yeah, now you guys can see it's actually changing, right? So it went to 2200, and I can like change it back down to like 2100, and then let's go down even more down. Damn, I'm destroying this. I'm literally destroying this board. Eat. So always make sure that you're taking a, okay, I'm just gonna do this with my nails. So always make sure that you're using a, what's it called? Screwdriver, yeah. Not
proper one. Not a pocket knife.
Not a, yeah. Anyways, I tried my best. So yeah, so wait. Oh wait, that might work. Give me that. Ooh.
I showed you this before.
You should have given me this before. Yeah, let's see. Does this work? Oh my God, it has a built-in LED.
Yeah.
Future is here.
I got this like 5 years ago or something.
Yeah.
Okay, this doesn't work. It seems to be corrupting the potentiometer anyways. It's okay. So you guys saw the data changing, right? Initially it was like 2100 and went up to 23 when I actually like spun it for a little bit. So yeah, that's what's supposed to happen. Anyways, so what else? So that's ADCs. Oh my God, I'm terrible. Yeah, that's it. Thank you for watching this video. Be sure to like and subscribe.